Hey everyone! So in this video, we're going to talk about the unit circle and certain recognition patterns that you can use to memorize it, and to memorize like the degrees, the radians, the coordinates of the unit circle. So right off the bat, some basics about the unit circle. First of all, the unit circle is a circle with the radius of 1. So what does that mean? At every point, since it's centered on the origin, at every point on the circle, the distance from the origin to that point will always be 1.
So using this Desmos calculator, you can see that no matter what the x and y values are, the hypotenuse is essentially always going to be 1.
So just right off the bat, if we simply graph it and graph the where it connects and crosses the axis, we'll get right here to be 1, 0, 0, 1. And this is just one starter off thing that I love to use and tell people, whoever I'm trying to teach this to, and that would be just divide up the signs of the quadrants in the corners, so it'll help you in the future and as we go progress into this video. So first quadrant is both x and y are going to be positive. So that's the starter pack, so to speak, of the unit circle. Alright, so in this section of the video, I'll teach you how to easily memorize the degrees of the circle. So obviously, as we've already learned in class, the entire circle will come out to a total degree of 360. So here we're going to start off with 0 degrees, and we're also going to end up with 360 degrees. And the easiest way to memorize this is keep cutting it. So if we cut the entire 360 in half, we're going to get 180 degrees over here. And if we cut that in half, we're going to get 90 degrees up here. And if we cut from 180 to 360 in half, we're going to get 270 degrees here. So now that we have the axis covered, we're going to start splitting the quadrants in half. Splitting the first quadrant in half, we're going to get 45 degrees. So here we have, this is not exact, but rough, we have 45 degrees. Here we're going to have not exact, but it's pretty rough. We're going to have 135 degrees. Alright, so now the easy way to remember the other degrees, I think, is from the quadrants, just subtract 15 and add 15. So to get that, we're going to get right here and right here. So if we subtract 15, we're going to get 30 degrees. If we add 15, we're going to get 60 degrees. And same as that, do that to each of the others. And there we go. We've labeled the degrees on the unit circles all correctly. Alright, so now in this section of the video, I'm going to be teaching you how to memorize easily the radians of the circle. So first of all, what are the radians? We notice that the degrees are measures of the angle in degrees starting from the origin, and then as we go up, they'll change. But what the radians is, it's the measure of the circumference of the circle. And I'm pretty sure all of you already know that the entire circle is 2 pi radians, but how did we get that? So we got that from the circumference formula, which we know if we learned it at all, which is 2 pi r. That's the circumference. And in our circle, since we said the radius is 1, we would have 2 pi times 1, which is the radius. What do we get? That equals 2 pi. And that is why we have 2 pi at the entire circle circumference. So first of all, we'll start off with 0 radians here, and we'll end with 2 pi radians here. And just as we did with the degrees, how we cut it up, we can cut this up too. So if we have 2 pi over here, we cut that in half. 2 pi over 2 will give us just pi. If we cut just pi in half, we'll get pi over 2. If we cut from pi to 2 pi in half, we're going to get 3 pi over 2. And going back to the first quadrant, if we cut pi over 2 in half, what are we going to get? Pi over 4. And just to keep going on this, you can think of the circle as cut into fourths now, so just keep adding 1/4 to everything. So this is essentially 1 pi over 4, this is 2 pi over 4. 2 pi over 4 reduced into pi over 2. Then the next fourth is going to be 3 pi over 4. 3 pi over 4. Next one's going to be 4 pi over 4, which is just pi. over 4. And adding our last fourth will take us to 2 pi, it'll take us to 8 pi over 4. And 8 pi over 4 is essentially 2 pi my bad. So now that we have the fourth completed, we could go on into the smaller degrees. And how I like to think about that is similar to the fourths, except this is divided into the sixth. So if we start off here with our first open blank, so to speak, we'll get pi over 6. Remember, this is 1 pi over 6 essentially. And then going on to the next blank, we'll get 2 pi over 6. And if we reduce that, that's pi over 3, right? And up to the axis, we're going to get 3 pi over 6. What is 3 pi over 6? Pi over 2. Then if we add 1 more pi over 6, we're going to get 4 pi over 6. 4 pi over 6 reduces into 2 pi over 3. And if we continue, that was 4 pi over 6, we're going to get 5 pi over 6 here. And since we were at 9 pi, we're going to add one more, 10 pi over 6. 10 pi over 6, if you reduce it, you're going to get 5 pi over 3. And we were at 10, now we add one more, 11 pi over 6. So here, that does not reduce, so we're going to put 11 pi over 6, and back to give us the full circle, which is going to be 12 pi over 6, and that reduces, till we already have it here, 2 pi. And that's how you label the radians of the unit circle. Alright, so now for this section of the video, I'm going to teach how to memorize and easily place the coordinates of the unit circle. So with each degree, there's a corresponding, each degree and each radian, there's a corresponding coordinate that goes with it. So the easiest way I've found, and I've learned throughout my years to memorize that, is like this. So at each thing, just put a fraction of 2 for the x and y position. So you're going to get over 2 over 2. Here you're going to get over 2 over 2. Here you're going to get over 2 over 2. And I wrote that a little big so we can all see. And what you do from here right now is just go 1, 2, 3 down, and then 1, 2, 3 up. And now you take the square root of all the tops. Square root of 1 is going to be 1, so you just leave it there. And we're going to have square root of 3. We're going to have square root of 2, square root of 2, square root of 3, and square root of 1. And once again, it's just 1. And now we're going to basically mirror that onto this side. So if we make the same things again. So basically we mirror this side, this quadrant right here, over onto this side. So we're going to get going down 1, 2. We mirrored it, except this time, remember in the beginning of the video we talked about the signs. So this time we apply the signs, and all the x values are going to be negative. So we're going to have negative right here. We're going to have a negative right there. There's not enough space there, but there's a negative also right there. So that's, we have this side. And to find the bottom, once again, we're mirroring it, and you can think of it logically as well. For example, if this point, we are going this much x distance out, and then we're going 1/2 up. So we're going to go rad 3 over 2 across, and then 1/2 up. For this point down here, we're doing the same thing. We're going rad 3 over 2 out, except instead of going 1/2 up, we're going negative 1/2 down. Although my drawing is not completely to scale, if it were to scale, that's what it would look like. So if we wrote the points here, it would be the same x value, which is rad 3 over 2, except since we're going negative 1/2 down, it would be negative 1/2 here. And following that same thing here, for the 45-degree point, we're going to go this much outside, and we're going to go rad 2 over 2 up. For this point, we're going to go the same x value across, except we're going to go negative rad 2 over 2. So same x value right here, except negative rad 2 over 2 y value here. So basically following that logic, so now that we've completed it, and once again remember the signs. They're very important, otherwise they'll mess your calculations up in the future. Alright, so now for just a few basic kinds of problems so you guys can understand the concept behind each of them. So one of the most popular problems are conversion problems based on the unit circle. So for this, we just have to memorize a simple basic formula. So if we want to go from degrees to radians, from degrees to radians, essentially what we would do is our degree value, will multiply that by pi over 180, and that would give us the radian value. So a quick example for that would be, let's just say you choose 270 degrees. So 270 degrees, we're going to multiply that by pi over 180, like using the equation up there. So 270 degrees equals 3 pi over 2 radians. And similarly, if we want to go from, here, let me switch colors just for sake of it. If we want to switch from radians to degrees, we would follow a similar equation, except it would be the reciprocal of that. So whatever radians we had, we would multiply that by, instead of pi over 180, it would be 180 over pi, and that would give us the degree. So a quick example for that would be, let's just say if we took pi over 6, for example. So we have pi over 6. That means, according to the formula, we'll multiply by 180 over pi. So that our answer for pi over 6 radians conversion would be 30 degrees. Now for the next type of problem, and this is also common, and this is called find the value kind of problems. Except this time we'll use the unit circle to our advantage, so everything goes much quicker. For example, if we take the problem, what is the cosine of 7 pi over 6? So what is the cosine of 7 pi over 6? If we utilize our unit circle back here, all we have to do is find that value. So looking at the unit circle, we'll go over to 7 pi over 6. 7 pi over 6 right here, 7 pi over 6. And since we know that the cosine is the x value, that's basically our answer right there, negative 3 over 2. So when we have this problem, the answer is essentially 3 over 2, negative 3 over 2. So you just copy that over. And if we were to do one more example like that, a little bit more trickier example would be, for example, tangent of, let's say, 4 pi over 3. What would that be? And since we know that tangent is essentially, on the side, is sine over cosine, we can use that to our advantage. So at 4 pi over 3, we try to find that. Where is that? 4 pi over 3, right here, down here. Let's see if I can fit that both. So we know that 4 pi over 3 are these values right here. The sine value is the y value, and the cosine is the x value. So if we set that up, if tangent equals sine over cosine, when we set that up, it should look something like, and once you simplify this out, we are going to end up with rad 3, and that will be our answer. So that's a little bit more complicated, and same thing goes back to these. They could ask you tangent or cotangent or anything like that. So thank you for watching this video, and I hope it was helpful.